Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit, and in this series we are discussing the printing electronics, and in the printing electronics we are discussing the various type of printing technology, in which we have discussed the contact printing. Now we will discuss the non-contact printing technologies. As compared to the contact printing technologies, the non-contact has the advantage of the substrate only getting in the contact with the deposition material. Now in the previous one we do not have a contact between the substrate and the ink. Now we just having the contact with the deposition material with the substrate. So this lowers the risk of contamination, of damaging the substrate, and the pattern's alignment is more accurate in this type of technique. So this last issue is an indispensable functionality of the pattern multi-layered devices. Means by using this we can prepare the multi-layered devices, also multi-layer circuits we can prepare by using the non-contact printing. So in the non-contact printing techniques there is no need for the physical mask of the to be printed images, only requiring a digital image. Sometimes just we have a structure, then we have a digital image. So by using that digital image we can put, simplifying the switching process without no additional cost. However, the non-contact technologies also stumble upon some difficulties when completing multi-layered devices are needed. So they work with all kind of the substrates such as wood, glass, metals, and the most interesting rubber, polymer, which require the low processing temperature and the risk to be damaged and deformed when subjected to thermal stresses and high temperature processes. And by using this we can prepare the flexible circuit, flexible devices also. Main non-contact printing techniques are described by using the following methods. So the main non-contact printing techniques are described in the following. Number 1 is the laser direct writing. Number 2, aerosol jet printing. Number 3 is the inkjet printing. Number 4 is the electro-hydrodynamic, that is also known as the EDH printing, and the last is the slot die coater, or sometimes it is called a slot mold coater. So we discuss one by one of the each technique. First we discuss the laser direct writing. As the name suggests, we take the laser and we just write directly on the substrate by using the laser. That is a non-contact technique, and the laser direct writing techniques enables to realization of the 1D to the 3D structure by the laser, induced deposition of the metal, semiconductor, polymers and the ceramics without using the mask, without the physical contact between a tool or the nozzle and the substrate material. Directly just we give the structure, and through the laser that structure is just print or the write on the substrate. So operated by a computer, a laser pulses are manipulated to control the composition, structure and the properties of individual three-dimensional volumes of the material across the length scale spanning 6 order of magnitude from nanometers to millimeters. So the ability to process complex or delicate material systems and the achieved resolutions enable LDW, means laser direct writing, to fabricate structure that are not possible to generate using the other techniques. Within the LDW there are the 3 writing techniques. What are these? In this just we have the L LDW addition techniques, where the materials can be deposited from the gaseous, liquid and the solid precursors. So, by using the gaseous, liquid, solid precursors, we can print the circuit. So, laser chemical evaporation technique are used, and by transfer by the laser beam from an optically transparent support onto a parallel substrate, we can have the laser induced forward transfer. That is also called a lift. That technique we will use for the preparation of the printing or the writing on the substrate. These techniques entail high cost due to the sophisticated instrument. For example, reaction chamber associated with the vacuum equipment, and it does not allow to deposit the organic substrate. So, it can only print on the flat substrates parallel to the support material. So, another type of technique is the LDW subtraction. That technique where the material is removed by the ablation. We use the laser ablation techniques and we remove the material, and a particular structure will be created. For example, photochemical, photothermal and photophysical ablation, laser scribing, cutting, drilling and etching methods has been used in this. So, an industrial application example is the high resolution manufacturing and texturing of stents or other implantable biomaterials has been prepared by using this. The third technique is the LDW modification technique, where the material is modified thermally or chemically. Easy laser enhanced electroless plating has been used. So, the substrate is submerged in a chemical solution that contains the metallic ions required for the deposition. So, a laser beam is responsible for the local temperature rise, decomposing the liquid and leading to the deposition of the metallic layer on the substrate surface. So, the main disadvantages relies in its disability to create the 3D structure. We can have the 2D or 1D structure on the substrate. You see on the screen that this is the method for the laser direct writing. You can see here that transfer the laser beam has been transferred and it is having a transparent carrier. Moreover, the thin source film, and by relieving the and receiving the substrate, the pattern is received by this. And another type technique is also there is a aerogel printing, inject printing, that we will discuss in the later. So, next is the aerogel printing. So, this aerogel printing, also known as the maskless mesoscale materials. So, that deposition technique is M3D, is another material deposition technique for printed electronic development by Optomac. So, the ink, where we use ink, that is a solution, and the nanoparticle suspension based on the metal, alloys, ceramics, polymers, adhesives or the biomaterials is placed into an atomizer. So, where we are having the arrows in the liquid particles of diameter between the 20 nano and 5 micro. You can see that here we also deposit the nanofilms on the nanostructure, because we are having the so much diameter, that is a 20 nanometer and 5 micrometer depending on the ink viscosity, and we print and we write by using this aerosol jet printing. So, then the ink is transported into the deposition head by nitrogen flow. The aerosol being focused by the jet stream onto the substrate. Means we are having a jet type of structure, and through which the ink has been thrown, and that is done under the nitrogen flow, so that it can cool the surface. So, as being a low temperature processes, many material and the substrates can be handled by the aerosol jet printing. So this technique is also scalable to support the high volume production needs, and it is suitable for non-planar capability, and the complex designs could be printed, or just like we can have a displays, we have a thin film transistors, TFT, solar cells that can be prepared by using this technique. The complex conformal surfaces, that is 3D printed electronics, are also possible by using this technique. The ability to control the position in the z direction of the writing head over the substrate. So, which it means that we can control the flow of the ink in the particular direction. So, this techniques also stumbles upon the some difficulties, like the droplet carriers creates a cloud of the power in the surroundings of the printing area. The sheath gas we can have creates a localized crystallization and solidification phase at the trace pattern, reducing the localized bonding layer techniques. So, the aerosol process is driven by the gas flow, where a mist of micro droplets is generated as a result of pneumatic atomization or through the ultrasonication, just we are having the mist of the micro droplets that will spread on the substrate, and that a desired texture is created. So, capability to process a wide variety of the material and to pattern the high resolution as high as 10 micrometer on the diverse substrate makes aerosol jet printing most attractive among other contact-less printing techniques. Moreover, the aero jet printing is divided into the two main categories. One is the pneumatic, another is the ultrasonic. Both the techniques are based on the different operational procedures and use the targeting specific set of requirements and the goals. For instance, if we talk about the pneumatic atomizer, then aerosol mist is generated by the supplying the pressurized air, and pressurized air or the gas we can take inside a closed chamber containing the ink, which result in the generation of the micro droplet close to the ink and air interfaces. Means that we are having a micro droplets that micro droplets ranging in the less than 5 micrometer diameter. It must be and are entrained in the supplied gas are driven towards the nozzle beneath. So, whereas the second case, the ink contained in a delicate vial and is subjected to ultrasonicated, and the micro droplet are generated as a result of ultrasonic pressure waves, and these micro droplets is having the size range again less than 5 micrometer and are entrained in the atomizer gas, which is driven towards the nozzle print head. Another accompanying gas, that is the seed gas, flowing along with the nozzle orifice sizes, and that leads to define the pattern size to be printed on the target substrate. So, pneumatic atomizer requires the more material, more than 10 ml, and is usually used for the wide area printing. On the other hand, ultrasonic aerosol requires only the 0.5 ml of the solution and can be used for printing at very high resolution pattern. For example, the 10 micrometer, for instance. So, the both techniques are used accordingly, but the best technique in these two are the ultrasonic aerosol technique. The gas flow reduces the size of the mist inside the carrier tube, which is accompanied by the sheath gas at the nozzle printable. So, now that this gas flow further covers the aerosol stream and reaches the surface at the higher impact. So, the aerosol mist is ejected in the form of the intake jet. So, stage speed adjusted in such a way that the desired pattern are deposited in the continuous fashion. You can see on the screen that this is the aerosol. These two techniques are defined here, pneumatic and ultrasonic aerosol jet techniques. You can see easily that how the pressure is generated and how the nozzle produces the mist of the ink, and the micro droplets are generated and deposited on the substrate. You can see both the side, almost these techniques are same, but the resolution in the ultrasonic aerosol is more as compared to the pneumatic technique. Another technique is the inkjet printing. This is the non-contact technique, and in this type of technique the inkjet is a new technology, and nowadays it is used for development of the electronic devices, and the mass production can be done by using this inkjet printing. So, inkjet printing is a new technology with a grown interest from a scientific community and is considered to be early stage of the development. In this inkjet printing technique, that is also known as the IPT, a content stored in the digital format is transferred by a direct deposition from the small opening in the print heads without the use of mask and without contact between the print head and the substrate, or droplet fluid or the powder protein or the minerals, conductive polymers, nanoparticles and a wide range of materials, e.g. for example, we are having a bioactive fluids which cannot tolerate exposure to photolithography and etching chemicals present in conventional techniques. Under the print head ejection, the gravity force and the air resistance, the ink is projected onto a specified position of the substrate, creating the printing patterns. And in the case of the fluids, it dries through the evaporation of the solvent by the chemical changes. And for example, if you take the cross linking of the polymers or the crystallization, eventually a post processing treatment is required as the thermal annealing or the sintering. So, when compared to the other deposition methods, IPT is adaptable for patterning on a high variety of the substrates with low consumption of the raw materials and low levels of waste production, harmful production to the environment. So, in which we can take the high variety, like we have the rigid or the flexible, smooth or the rough surfaces, or the substrate we can use that are the glass, plastic, paper, textile that are flexible. We can use the flexible surfaces for the deposition. So, this is a very common and very interesting method nowadays. IPT is intended for a wide range of application for the production of the transducers, transistors, structural polymers and the ceramics, biomimetic and biomedical materials printed for the growth of the living tissues, as well as the building the 3D electric circuits. We can prepare the MEMS, we can prepare the sensors on a single substrate. We can just print the thousands of structures that can be further used. No special processing conditions are needed in this. So, IPT stands out for being a one-step process with a simple operating principle, reduced number of manufacturing steps, with the possibility of using the low cost raw material. Mass generation is more in this technique. Thickness around the nanometer range is easily achieved by increasing the electric field value along with the distance between the print head and the substrate. The used inks have a particular set of the physical specifications in the particular its viscosity, the superficial tension and the amount of the humectant. So, that is used for the inkjet printing. So, in this sometimes in this technique sometime modification on the ink viscosity, concentration and the solvent systems are necessary for proper droplet injection, and moreover without blocking the nozzle. So, it is very important to keep the viscosity and concentration of the ink in a proper method so that it will not block the nozzle. And continuously the cleaning is very important whenever we use one type of ink, that must be semiconductor ink, then we will clean it accordingly so that the another ink can be filled without affecting the structure. So, although the low process velocity and possible clogging of the nozzles presenting challenges to industrial production, IPT becomes ideal for laboratory research, providing the innovative fabrication, high quality and low cost production. Mainly the two mechanisms for the actuation of the inkjet nozzle head have been developed. Number one is the thermal, second is the piezoelectric. As you see on the screen, we have a two mechanism. First is the thermal, second is the piezoelectric. Droplets is very small diameters are ejected at a each corresponding pulse and generated by either thermal or by the piezoelectric actuators used in the inkjet nozzle head. In the inkjet nozzle head, we use the two type of pulses, that is the one because of the thermal, second is the piezoelectric. So, in the schematic we show that the mechanism of the droplet injection through the piezoelectric thermal inkjet material printer. Typically the nozzle diameter used for the inkjet head range from 10 to 150 micrometer and the ink with the volume capacity of the 3 ml. So, you see on the screen, this is the most common method, droplet actuation mechanism of the inkjet material printer. Now, you see here we are having a reservoir, ink reservoir. Now, we are having the AG ink, silver ink we are using, that is a silver nano ink, that is the piezoelectric or the thermal element we will use, that is the nozzle. So, the pressure will be given, the ink droplet will be produced through the nozzle and that will be print on the on the substrate. A pattern has been decided on the computer. After that, by using this inkjet printer, it is printed on the substrate. So, the pattern or the films can be developed on the substrate. So, the actuating element is either thermal or piezoelectric. In case of the thermal actuators, a filament is embedded in the nozzle head and upon the voltage application. So, the bubble is generated in the nozzle that pushes ink to the nozzle tip and generates the droplet. In case of the piezoelectric element, piezoelectric crystal is placed inside the nozzle and upon the voltage application, piezoelectric crystal vibrates and as a result pressure exerts on the ink inside the nozzle and the droplet generates. So, now we have seen the droplet actuation mechanism of the inkjet material printer. Ink is filled in the reservoir. So, the driving signal is applied to the actuating element that generates the droplets according to the design geometry. So, the inkjet printers are further divided into the two types as continue inkjet and the drop on demand. So, the output of the ink can be classified the inkjet printer, that is a continuous inkjet, that is known as CIJ, and another type is the drop on demand system. In continuous inkjet printer, the ink is stored in the reservoir supplied to the nozzle. A charge electrode is used to pull the ink out to the nozzle from a droplet. After droplet formation, deflection plates are used to direct the droplet on the targeted area on the substrate. This kind of printing system is used in the industry for printing on the packages such as expiry date, commonly seen on the boxes and the drinks or the liquid bottles. So, we just have that type of technology. So, as the droplet are not controlled by any input signal, so CIG system continuously produces the droplet with a certain frequency, hence the unused droplet are directed to the recycling system where the ink is stored and reused. On the other hand, if we talk about the DOD, so in this system, the system is controlled by the digital input signal that comes from the design of the pattern. In the DOD system, each droplet is generated on demand, hence there is no need of deflection and the charge electrodes. So, substrate is kept perpendicular to the nozzle and the droplets sit on the substrate one by one and the pattern is prepared. So, the substrate is moved separately through a control system synchronized with the droplet generation in order to make a pattern or a thin film on the substrate. And the number of nozzles is commercially. In the commercial inkjet printed ranges from the 1 to 128 ink droplets as small as 1 pl. So, you can see on the screen, one is the continuous and the second is drop in demand inkjet system. Both are working in the similar. Recycle is there in that of the continuous inkjet, and here this work on the drop work on the controlled signal controlled manner. So, up to now we have discussed the non-contact printing and the various type of non-contact printing we have defined. Further we will define the types of non-contact printing in the further lecture, that will be the printing technology without contacting with the substrate. Thank you very much. In this lecture, we just defined the contact technique. Moreover, we defined the non-contact technique. In the non-contact technique, we define the inkjet printing, which is the most important, aerogel, direct printing, laser printing. Now, further, we will define the other type of the printing in the next lecture. Thank you very much.